I would like to present the paper Performance-Based GNSS Satellite Selection, an LMI approach. My name is Ji-Qin Zhuang. The problem is to select appropriate number of satellites so that we can balance the performance and complexity. And the problem formulation is as follows: that we are given the measurement equation, we know how to obtain the estimate, and then we can then evaluate the performance. Typically, we try to optimize the performance to determine the estimate. And if we take the consideration of satellite selection, then the performance objective function may become as follows. So that's mean in addition to the performance metric you want to select, in addition to a noise statistic, we also have the S matrix which related to a satellite selection. And S matrix, a diagonal matrix, that's a 0-1 matrix. So the problem can then be formulated as a determination of the 0-1 matrix, so to minimize the performance. So we convert this problem into LMI problem, that's using the linear metric inequality. So the problem is to determine S and M, which is a matrix that satisfies the metric inequality. But because S is a 0-1 matrix, it's numerical difficult to determine. So we relax the problem to determine the real matrix bounded, and then that's become the problem. And this problem it become feasible to solve. And more importantly, by solving the problem, we can obtain the upper bound and lower bound of the performance. So this is especially important to mention. This lower bound is important because it's new, and during the selection, once we know the upper and lower bound, we know how good we are doing. And we perform certain simulation and compare our result with existing method and highlight the significance of this LMI approach and some other alternative. And also we address the multi-epoch satellite selection, so that's the satellite the receiver do not have to switch the selection too often, and this problem can then all be dealt with under the same framework. In summary, we address the satellite selection problem within the LMI approach, and that gives us both upper and lower bound, and we believe this is a good method for satellite selection. Thank you.